All right, so this is the video for the notes on transformations of quadratic functions. And this is going to feel really familiar to what we did on absolute value functions because the transformations are the same. You recognize them the same way. You kind of work with them the same way. You can still find the vertex the same way. The only difference is instead of having a V-shaped graph like we did with absolute value, we have a U-shaped graph now. So just a little reminder about the different transformations. The A in the front tells you about the vertical stretch or the vertical compression, and it can also tell you if the graph has been reflected over the x-axis, which for us just looks like it's flipped upside down. So we're going to say if A is negative, then that means that the graph has been flipped. Which we call reflect over the x-axis. That's the formal way of saying it, so that's how we write it. If the absolute value of A is greater than 1, so it doesn't matter if the A is positive, it doesn't matter if it's negative, we're just worried about the size of the number. If it's 2, or if it's 1.5, or if it's -7, or if it's -3/2, anything like that, we call a vertical stretch. If the absolute value of A is less than 1, maybe it's 2/3, maybe it's -1/2, maybe it's 3/5, maybe it's -0.7, any of those would be a vertical compression. And this should feel familiar to you because this is exactly the same as what we've already done. So those are all the transformations you can see from the coefficient. Inside the parentheses, we have -h. So if that number is a positive, it would move the graph to the left. So remember, that's kind of the opposite of what you would think. If that number is a negative, it moves the graph to the right. And then for the number on the end, if that number is positive, it moves the graph up. If that's negative, it moves the graph down. All right, as far as the overall shape of a parabola, this is the parent function we have, y = x squared. It has no transformations to it when you write it like this. So if we think about plugging the numbers of x in for the x squared, we have -3 squared, which is -3 times itself, that's 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So I'm starting here at 0, 0, and then I've got -1, 1, +1, 1, -2, 4, +2, 4, -3, 9, +3, 9. So you'll notice that when this goes up, it increases more rapidly each time. That's what gives it that U shape. So when you connect these, you have to be really careful to make it look like a U so that it doesn't look like those absolute value graphs. You should be able to look at the graph and notice that it distinctively looks different. So the interesting thing about parabolas, if they don't have a stretch and they don't have a compression, is that they go up by the odd numbers. So from 0 to 1, you go up 1. From 1 to 4, you go up 3. From 4 to 9, you go up 5. And then if we had more space on the graph, next you would go up 7, then you would go up 9, then you would go up 11. So with absolute value graphs, we just remembered, oh, it goes over 1 up 1, over 1 up 1. That's different this time. It goes over 1 up 1, over 1 up 3, over 1 up 5. All right, so for some of you who stopped using Desmos or stopped using your graphing calculators because you could kind of graph them by hand, at this point you might want to use Desmos a little bit more often. All right, so we're going to go ahead and find some information for each of the equations. We're going to write the transformations, we're going to write the vertex, and then from there we're going to make sure that we can graph this. So I've got y = 2 times x - 2 squared plus 3. The little exponent here is what tells you that this is a parabola. It tells you that this is a quadratic. So that is not considered to be a transformation. That's why I did not write any notes on it. I ignored it. I just looked at the A, the H, and the K. So here I'm looking in the front, I can see that we have a vertical stretch of 2. The 2 inside tells us that we're going to the right 2. And the plus 3 on the end tells us that we're going up 3. All right, next I'm going to go ahead and write this out just because these are the notes. And so it's kind of helpful to have something a little bit more descriptive in your notes. So I'm looking at this number and I'm looking at that number to find the vertex. And just like we did with absolute value graphs, the vertex is the opposite of the inside number, and it's exactly the same as the outside number. So the vertex is over 2 up 3. Okay, so let's go ahead and graph this on Desmos now. All right, so y equals 2 times x minus 2. To do squared, you can use Shift 6 if you're on a computer. If you are on a cell phone, or still on a computer and you just don't want to type it like that, then you can actually go down here. There's this keyboard button. This automatically shows up when you're on your phone. And you can hit the squared button to get that exponent of 2 there. So 2 times x minus 2 squared plus 3, here's the vertex right here. And we can see, so a normal quadratic would go over 1 up 1, over 1 up 3, over 1 up 5. This one has a stretch of 2. So instead of 1, 3, 5, it does 2, 6, 10. So it just doubles how much it goes up each time. So you can see it goes over 1 up 2. And then the next one, there's our vertex, over 1 up 2, over 1 up 6 is how far we have to go to get to the next square. So over 1 up 2, over 1 up 6, I'm going to go ahead and graph that on my paper. So over 1 up 2, over 1 up 6 is just a little bit off the graph, so I'm going to go ahead and draw it anyway. And then I'm just making sure that this is still kind of U-shaped, even though it got real skinny that time. I'm just making sure it doesn't look like a V, because I want to know for sure that it's different than those absolute value graphs. All right, for the next one, we have an inequality here. That means I'm going to graph it, but I have to think about if it's a dotted line or a solid line. And then once I do that, I have to figure out where to shade. So in the front, I have a negative. That negative tells me that the graph has been reflected over the x-axis. I'm going to be drawing that graph upside down. It also moves to the left 4 and down 5. When I look for the vertex, I can see that the vertex is the opposite of this number, that's -4, and then exactly the same as that number, -5. So left 4, down 5, it's got a negative in the front of it. So I can go ahead, actually I'm going to draw this by hand and then I'll show you on Desmos. So the pattern is 1, 3, 5. So I'm going to go over 1, down 1, over 1, down 1, and then over 1, down 3. And I do not have space to do the over 1, down 5, so I'm not going to worry about it. The inequality symbol tells me that this should be a solid line. It's got an equal to, that's a solid line. And then I need to figure out where my shading is. So to figure out the shading, you're either going to shade inside the parabola or outside the parabola. 0, 0 is always a good point to use. It's just really easy to plug in. So if I use the point 0, 0 to figure out my shading, I'm going to plug 0 in for the y coordinate. 0 is less than or equal to negative of 0 plus 4 squared minus 5. All right, 0 plus 4 is 4. And then 4 squared is 16. So we have 0 is less than or equal to -21. 0 is not less than a negative number, that is false. So here's 0, that means that this area here is false. Outside of the parabola is false, that means that inside the parabola is true. And that's where we do the shading, is inside of that quadratic, that U shape. Okay, so I do want to make sure that you guys can graph that on Desmos. So if we look at Desmos, I'm going to go ahead and type that in. I have negative x plus 4 squared, and then I've got the minus 5. Let me go ahead and move this. So there's the parabola right there. Now, if I want to have the inequality part, I've got y, and I have to type less than or equal to. So what I do is I hit the less than key first, and you can see it shifted. It made it a dotted line for me, and it shaded it for me. For me to do a less than or equal to sign, I have to go here now, and I have to press the equal to sign after the less than sign. And what it's going to do is it's going to throw a little line underneath and make it an equal to. And you can see that when it did that, there's my little line underneath, it actually fixed the graph for me and made it solid. So if you have an inequality that you're graphing, you can graph it on Desmos. You just have to make sure that you type that symbol correctly. All right, let's go ahead and go back to the notes and do the very last problem. So we've got the 1/2 in the front. That is a vertical compression. And then we have the +1, that's left 1. We have the -7, that is down 7. All right, so I've got the vertex. The vertex is at -1, -7. So I'll graph that -1, -7. This graph is not upside down, it is right side up. It's a compression of 1/2. And so instead of going up 1, up 3, up 5, up 7, it's going to go up 1/2, and then up 3 halves, and then up 5 halves, and then up 7 halves. So 1/2, and then I've got 1/2, 2/2, 3 halves is right there. And then 1, 2, 3, 4, 5, 6, 7 halves is right there. So this one, if you guys remember, that vertical compression makes the graph appear to be very wide, or not super wide, but definitely wider than normal. So if that was difficult for you, if you don't think that you can follow that pattern by hand, you can always type it in Desmos. And so that's what we're going to go ahead and do next, is just make sure that we can type this without an issue. So I would have y equals 1/2, and then x plus 1 squared minus 7. And you can just look for where it goes through a corner. So it goes through a corner right here, and then it goes through a corner right there. And that could be where you plot your points.